Hello and welcome to another science revision video. Now in this video we're going to look at empirical formulae. So let's dive in and get started. First of all, finding chemical formulae experimentally. Now we can do, as shown in this little diagram here, we can conduct experiments with compounds to determine the mass or percentage there is of each element. For example, we could heat magnesium in air. Now magnesium oxide would be formed. And of course the mass will be increased because oxygen is being added. So we may get the following results table. Over here we've got mass of magnesium. There were actually three trials here. Mass of magnesium first trial, second trial and the third trial. Over here the mass of magnesium oxide. Now by subtracting this figure from this figure, that would tell us how much oxygen was actually produced in each case. We can see here the first case 0.017, 0.004 and 0.109. Now to find the chemical formulae we simply need to choose one of these. But before we start, let's just have a definition, shall we? Let's stop there just a second. There's a term here called empirical formula. What does it mean? Empirical formula. Well, empirical formula is the simplest whole number ratio of atoms in any compound. Okay? The simplest whole number ratio of atoms in a compound. Sounds confusing? Well, let's have a look at an example, shall we? Let's calculate the empirical formulae for magnesium oxide. To do that, let's go back to our results table, and here we're going to just take two results. Let's take the third one here. So this one, we got mass of magnesium, and what was produced? This much oxygen. Okay, so from these two bits here we can calculate the empirical formulae. Now what you need to do is follow through the process very carefully as we do it. So, empirical formula. Now I find when I'm doing these sort of calculations, I always find it easiest to have like a standard format I lay things out in. So here's a standard table. Now this is a table I would use to calculate empirical formula. First of all, the elements, magnesium and oxygen. What are the reacting masses? Well, we know from our results table it's 0.16 and 0.109. Relative atomic mass. Now do you remember this? We can get this, can't we, from our periodic table. Magnesium 24, oxygen 16. Now, number of moles. We did this last time. Did this in the last video. Number of moles is the mass used divided by the relative atomic mass or molecular mass. An example we had here was for sodium hydroxide. So, all we do here, we divide the mass by the relative atomic mass. So 0.160 divided by 24 is, let me think, it's, yes, 0.0067. 0.109 divided by 16 is 0.0068. Now what we do is very simple. We simply find the smaller number. Which is the smaller number? These two, well, obviously is this one here. So we divide both numbers by the smallest one. So that divided by itself, and then 0.0068 over 0.0067, work out the answer, and in both cases it's near enough 1. So basically one atom of magnesium reacts with one atom of oxygen. And what have we done? We just calculated the empirical formula. Let's have a look. So empirical formula, we said it's 1 and 1. So it is MgO. Well done. That wasn't so hard, was it? Let's look at another example here. Iron and oxygen. We need to look first of all at the mass that's reacting. So 2.24 grams of iron reacts with 0.96 grams of oxygen. And again, look at the atomic masses. Remember I said about keeping a standard format. Always keep a standard format. 56, 16. Number of moles, okay, you can do that divided by that. Let's have a look. 0.04, 0.06. Which is smaller? That one. So divide both sides by the smallest. So 0.04 over 0.04 and 0.06 over 0.04. Now you work these out, you find you get the ratio 1 to 1.5. Right, they're not whole numbers. What should we do? Well, what we do in this case here is simply double it. So end up with 2 to 3. So the reacting ratio is 2 ions to 3 oxygens. Now I think from this you can quite easily see we can put down the empirical formula as Fe2O3. Now, we don't always need to talk about mass in grams. We can talk mass as percentage. So, the percentage of magnesium we found was 60% magnesium and 40% oxygen. Don't worry, don't panic. Keep exactly the same rules we had before. Lay it out as we had before. So look up the atomic masses, 24, 16. Okay, so number of moles is simply that over that. 60 over 24 is 2.5. 40 over 16, 2.5. You see what we've done here? It doesn't matter if this is grams or percent. Treat it exactly the same. Now my simple ratio divided by the smallest, well, they're both 2.5, so it's 2.5 over 2.5, yeah, blah 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 blah, which equals 1. So we now know again that 1 magnesium reacts with 1 oxygen, therefore the empirical formula is MgO. Got it? Right, well, as always in these cases, we take the next step, the more difficult. So let's make a more difficult step and have 3 elements. Not 2 but 3. Calcium, carbon, oxygen. Again, let's look at the mass. So we found by reaction that 10 grams of calcium reacts to 3 grams of carbon and 12 grams of oxygen. Put in here relative atomic mass, 40, 12, 16. Where have they come from? The periodic table, remember? Number of moles is this figure divided by this divided by this, and this divided by this. So divide those and you get 0.25, 0.25, 0.75. Most simple ratio, divide by the smallest. Either of those two will do, won't it really? So we've got 0.25 over 0.25, 0.25 over 0.25, 0.75 over 0.25. Work out a reaction, so that must be 1, that must be 1, that must be 3. Let's see if I'm right. Look at that, spot on. So we've got 1 calcium, 1 carbon, 3 oxygens. So the empirical formula must be CaCO3. Okay? That wasn't so hard, was it?